Hi dear students, today let us start the new chapter, that is differential equations. Differential equation. Previously, you people have studied that what is the differentiation, how to differentiate the different kind of the functions and application of differentiation as well as a given function. Integration also you just did it. In the differentiation, several function differentiation you people did. For example, linear functions, quadratic function or polynomial function differentiation, trigonometric equations differentiation, and implicit function, explicit function, logarithmic function, exponential function, different type of the functions derivative people have did, as well as second order derivative also we did. So now, what is meant by differential equation? As we previously know that in a school level, what is meant by equation? What is the equation? Two expressions are said to be equal. Two expressions or two numbers are said to be equal. So here two expressions are equal. Two expressions are that is said to be equal. Then you can say that this is an equation. But here I need to tell that differential equation. What is the differential equation? First of all, in a previously, you people have taken 2x plus y is equal to 9. I just call this as the equation number 1. Yes, this is one expression, this is a number. Expression and a number or expression are equal, that is said to be a equation. Okay, this is the equation. Similarly, you people have taken 3x square plus 5x plus 12 is equal to 0. This is also an equation. This is the linear equation involving the two variables. This is a quadratic equation, or you can say that polynomial equation having the second order. So, linear. Now, here like that, several equations you have taken. Trigonometric equations means sin x plus cos y or sin x plus cos x is equal to 0. This is said to be a trigonometric equation like that. Implicit function, explicit function, x square plus xy plus y is equal to 0 or y square is equal to 0 like that. Exponential functions means e power x or f of x is equal to e power x plus e power x is equal to 0. Exponential function is that like that. A different type of the equations you people have seen. Now in this video we are going to know that what is the differential equation. Now I am just going to write one equation, that is differential equation, that is x into dy by dx plus y is equal to 0. The equation number 6 is said to be a differential equation. These are all the simply the equations: linear equation involving two variable, quadratic equation, trigonometric equation, implicit function, like that. Several equations are there. Out of this one, this is said to be a differential equation. What is the difference between all these equations? Now, so here difference, here variables are there. What are the variables? X and y are the two variables are there. So two variable, particularly name is that. What is the particular name? Y is said to be a dependent variable. Y is said to be a dependent variable. X is a independent variable. X is an independent variable, y is a dependent variable. In that, two variables are there. So always, if people used to write that y is equal to e power x, exponential function. Here x is an independent variable, y is a dependent variable. In that manner, you used to write it. On changing the x value, y value will be changes. So here x is independent. X is an independent variable, y is a dependent variable. Just particularly remember, because we need what is the independent variable, what is the dependent variable. Very important thing you have to remember. So always x is the independent variable, y is a dependent variable. Here in a previously people have taken this differentiation you just did. What is that differentiation with respect to x? Dy by dx is equal to e power x. Differentiation is e power x only. So this is said to be a differential equation. This is the exponential equation. This is our function, and this is said to be a differential equation. What is the difference between these two? What is the difference between here? Differentiation is types. So this type of equation are said to be a differential equation. Then what is the definition of the differential equation? An equation involving the derivative is called a differential equation. Simply we can divide another way. An equation involving derivative is said to be a differential equation. Other way we can say that more elaborately, an equation involving the derivative of the dependent variable. An equation involving the derivative of the dependent variable with respect to the independent variable. With respect to the independent variable is said to be a differential equation. What is a differential equation? A equation involving a derivative of the dependent variable, with respect to the independent variable. With respect to the independent variable is called differential equation. Is called the differential equation. What is the differential equation? An equation involving a derivative of dependent variable with respect to the independent variable. With respect to the independent variable is called a differential equation. So I just denote a differential equation only the differential equation. Here again this differential equation is going to divide into two parts. Two types are there in the differential equation. What are the two types are there? Means one is the ordinary differential equation. Ordinary differential equation. Another one is the partial differential equation. Ordinary differential equation and another one is the partial differential equation. In a differential equation, two types. What are the two types? One is the ordinary differential equation, another one is the partial differential equation. Ordinary differential equation you can simply write it as a ODE. Partial differential equation you can simply write it as a PDE. Ordinary differential equation, partial differential equation. Then which equations are said to be a? First of all, we need to consider the differential equation. In that differential equation, which one is the ordinary differential equation and which one is the partial differential equation? Okay. Ordinary differential equation. What is meant by ordinary differential equation? Means I just mentioned the definition. An equation and derivative a differential equation. Ordinary differential equation means I just write the thing here. ODE. A differential equation. A differential equation involving derivative of the dependent variable. Derivative of the dependent variable with respect to the one and only one independent variable. One and only one independent variable is said to be a ordinary differential equation. What is the ordinary differential equation? Equation or a differential equation. Differential equation means it exists a derivative of the dependent variable with respect to the independent variable. That is, the derivative of the dependent variable with respect to the one and only one independent variable. Here x is the independent variable, y is the dependent variable. Obviously we can say that it is ordinary differential equation because it satisfies our condition. What is our condition? Derivative of the dependent variable with respect to the one and only independent variable is there. Yes, obviously it is a ordinary differential equation. Here also derivative of the dependent variable y with respect to the independent variable x. Only one independent variable is there. This is said to be a ordinary differential equation. Next, partial differential equation. What is a partial differential equation? Equation or a differential equation. It involves a derivative of the dependent variable. Derivative of the dependent variable with respect to the one independent variable. With respect to the more than one independent variable. I got it? A differential equation involving a derivative of the dependent variable with respect to the more than one independent variable. That is said to be a partial differential equation. For the at this second year, you are going to study only the ordinary differential equation. You are not going to study the partial differential equation. So this partial differential equation you are going to study at the degree level. Now we are going to deal whatever the equations, differential equation are there, those are all ordinary differential equations, which means that derivative of the dependent variable with respect to the one and only one independent variable. In that manner we are going to study. Okay, particularly example we can take. What are the example we can take? It means first example already is that x into dy by dx plus 5 is equal to 0. This is the example number 6. Or equation number 6 is the required one. And equation number 7 particularly example. And similarly we can write that. What is that? X square into dy by dx plus sin of x is equal to 0. This is also a differential equation involving the only one variable, involving the only one independent variable x. This is said to be a differential equation like that. As several equations we can write. Next we can write that dy by dx whole square plus x into d square by dx square is equal to 0. This is said to be also a differential equation which is having involved the derivative of the independent variable y with respect to the one and only one independent variable x, like that. As several equations we will see. For example, in the particularly differentiation, that is second order derivative, this type of equation we have already seen. What are good? For example, 1 plus x square into d square by dx square plus x into dy by dx is equal to this type of equation you people are studying. These are all the differential equation, particularly ordinary differential equation. These are said to be particularly an ordinary differential equations. Is that clear? Now, this is all about the differential equation definition, and two types. One is the ordinary differential equation, another one is the partial differential equation. Very simple thing is that what is the differential equation? An equation involving the derivative of the dependent variable with respect to the independent variable is said to be a differential equation. Particular example, equation number 6, equation number 7, and these two, and here is these are all the differential equation. Laterwards, in the differential equation, two types. One is the ordinary differential equation, another one is the partial differential equation. What is the ordinary differential equation? An equation involving the derivative of the dependent variable with respect to the one and only one independent variable. What is the ordinary differential equation? You just mentioned the definition. An equation involving the derivative of dependent variable with respect to the one and only one independent variable. That type of equation is said to be a ordinary differential equation. Particular examples, equation number 6, equation number 7, these are all the ordinary differential equations. Next, partial differential equation. What is the partial differential equation? An equation involving the derivative of dependent variable with respect to the more than one independent variable. With respect to the more than one independent variable, like that. This is said to be a partial differential equation. Actually, these things you are going to study in the degree level. Particularly, if you want one example, means you can take it. Dou square by pi, dou x into dou y plus dou y by dou x is equal to 0. This type of equations are said to be a partial differential equation. Here, instead of writing the dy by dx, here we used to write that dou y by dou x or dou square y by dou x into dou y. That is nothing but once they have differentiated with respect to x, and another time they are differentiated with the variable y. That is nothing but these are the particular example of the partial differential equation, and these are the all equations are example of the ordinary differential equation. I hope you people are clear about this one. Very simple definitions are the three definitions, very important, remember. Particularly differential equation definition and ordinary differential equation definition compulsory you have to remember. This is not there in your syllabus, but we have to make the difference. What is the ordinary differential equation? What is the partial differential equation? For that reason, you have to remember the definition. Okay, now mention all these definitions and example. Now go to the next point, that is order and degree of the differential equation. Yes. Before going to order and degree of the differential equation and notation, we just take it. I think people have already taken the notations, representation. How to write the derivative, that is in the differentiation also you just taken that. Suppose y is equal to f of x, then differentiating with respect to x. Y is the dependent variable, x is the independent variable. dy by dx is equal to f dash of x. This is said to be a first order derivative. Again, if you differentiate this one, d square y by dx square. This is said to be a second order derivative, f double dash of x, like that. This one you can write as a y1 only. This we just write it as a y2. Or some people used to write that y dash and y double dash. In this manner, they used to represent. Similarly, dq y divided by dx cube. This we can write f triple dash of x. We can write as a y triple dash. In this manner we can write, or else we can write as a y3. So like that, up to n number of times you can make the difference. But all writing the n number of dashes is a little bit difficult. So that we can write that dn y divided by dxn. This we can write as a yn or y power n. So the better write the yn or f power n of x. In this manner also we can read. Instead of writing the number of dashes, we just write as a y3 or y2, y1 or y triple dash, y double dash, y dash, like that. In that manner we can denote it. Now this thing people already represented first order, second order in a second order derivative differentiation chapter. Okay, now next thing is order and degree of the differential equation. Previously, second order derivative people already studied. Given function twice, people already differentiated. Now exactly the definition you are going to study at this moment. What is the degree and what is the order of the differential equation? What is the first of all order of the differential equation? Order of the differential equation. What is the order of the differential equation? For the given differential equation, highest power of the or highest derivative of the dependent variable with respect to the independent variable. What is the order of the differential equation? Highest power or highest derivative of the dependent variable, highest derivative of the dependent variable with respect to the independent variable. With respect to the independent variable is said to be the order of the differential equation. This highest power always an integer, particularly a positive integer. Order is always measured in a positive integer, because how many times you are differentiated, how many times these, always you have to consider the positive integers or natural numbers. Come to here, this is a real function is that if you differentiate it once, that is dy by dx is equal to f dash of x. None of them the same, notation is different. Either you can represent in this manner or represent in this manner or in this manner, nothing to worry. Again, if you differentiate it, if you are differentiated twice, then we just used to write that d square y by dx square. Differentiation of the dependent variable y with respect to the independent variable x, that is said to be a second order. third order. It is all said here order of the differential equation. First order differential equation, second order differential equation, third order differential equation, nth order differential equation. Order means highest power of the derivative. Highest power of the derivative present in the given differential equation. This is simple one. Or else highest power of the derivative of the dependent variable with respect to the independent variable. Either you can remember in the first manner or in the second manner. What is the simple thing? Order means highest power of the differential or highest order derivative. Highest, maximum how many times they are differentiated, that we have to write it. For example, I'll just take a few examples. Previously also this is taken up example, that is dy by dx is equal to e power x and x into dy by dx whole square plus y is equal to 0, or else you can say that d square y by dx square plus x into dy by dx plus 2 is equal to 0. For 1 plus x square into d square y by dx square plus x into dy by dx is equal to 0. So these are all plus y is equal to 0. These are all the several examples I just taken. Now people need to recognize that order of the differential equation. What is the order? Order means highest power of the or highest derivative of the dependent variable with respect to the independent variable. The dependent variable or independent variable. Dependent variable na maximum s of the differentiation matter that order. So I am just going to write the order here. Order of the first example. What is the highest time they are differentiated for the dependent variable with respect to the independent variable? That is dy by dx. Order of the differential equation is 1. That should be a positive integer. Yes, 1 is the positive integer. Maximum. What is the highest order? That is nothing but dy by dx whole square is nothing but, don't write this one as a d square y by dx square. This is not an exact thing. What does that mean? dy by dx is that thing square we have to take it. So now what is the highest order? Maximum differentiation of this differential. Maximum differentiation is we can do how many times they are differentiated? Only one time they are differentiated, divided by dx, highest power, d power. What is that? 1 is that. This is also order is 1. Don't write it as a 2. Is that clear? This is order. Order means highest power or highest derivative of the dependent variable with respect to the independent variable. Here dy by dx whole square is the means first order is that value they have taken a square. Okay, order is 1 itself. Next, what is the order of this differential equation? Highest time derivative of the dependent variable with respect to the independent variable. Very clear definition is that. See, what is that? Highest power. Here once, here twice is that. So the order of the differential equation is 2. Next, what is the highest power? Whatever the coefficient doesn't matter. What is the highest power of the derivative of the dependent variable with respect to the independent variable? That is 2. This order is 2. Like that, in this manner, you have to write it. So I will take one more example. X into d square by dx square plus sine of dy by dx. Sine of dy by dx is equal to 0. What is the highest order derivative? Highest order derivative. Derivative must be present with the dependent variable. Derivative of the dependent variable, highest power with respect to the independent variable. X into d square by dx square plus sine of dy by dx is equal to 0. What is that? Highest power of the derivative is 2. Here 1 is that, here 2 is that, here is a. Obviously it is a differential equation, nothing to worry. Instead of the angle x or only the x angle, they have taken a derivative. First derivative as a angle they have taken. So this is also differential equation. Order is in this manner. You have to write the order. Now The next thing is degree of the differential equation. What is the degree of the differential equation? Degree of the differential equation. Yes. Here, to come to know that what is the degree of the differential equation, first of all you should know that polynomial in the derivative. Polynomial in the derivative. That is nothing but already know that polynomial equation involving the variable x. What is the polynomial equation? Polynomial equation is just already familiar that I just polynomial equation. For example, we can say that ax square plus bx plus c is equal to 0. What is the variable here? X is the variable. This is said to be a polynomial equation. And similarly, general form of the polynomial equation we can write as f of x is equal to a0 plus a1x plus a2x square plus 1 plus an into x power n. This is the nth degree polynomial equation. If you say that nth degree polynomial equation, provided that an is not equal to 0, x is the variable, and a0, a1, a2 coefficients of the variable are all any real number, positive or negative, whatever the real number. This is said to be a nth degree polynomial equation. Variable is what? Variable is x itself. Is that clear? Here also variable is x. Obviously, it is a particular example of the polynomial equation, quadratic equation, cubic equation. These are all the particular example of the polynomial equation or polynomial functions. So polynomial in x is nothing but a function which has the variable is x only. Remaining are all the functions. Now, polynomial in a derivative means in place of this variable x, the polynomial derivative means that should contain y dash or y double dash or y triple dash, so on, etc. Polynomial derivative means the derivative is becomes a variable. For example, not exactly the variable, come to here. First equation is that dy by x is equal to e power x. Obviously, it is polynomial in a derivative. That means dy by x. This means y dash is equal to e power x. Obviously, can write. Then x into dy by x is that. So these are all the first four equations. There is no problem at all. Come for the fifth example. What is the fifth example? Is that x into d square y by dx square plus sine of dy by dx is equal to 0. This differential equation is not a polynomial in derivative. It is not a polynomial in derivative. Have you got my point? What is that? These first four examples are polynomial in derivative. Fifth one is not a polynomial in derivative. What is the reason? Means here derivative is assumed as a variable, but sign of that derivative is there. This is not becomes a polynomial, because polynomial means what are those? A0, A1, A2, A3, so on. N are the any real number, x is the variable. But instead of this one, if I introduce this one, ax square plus bx plus sine of x is equal to 0. This is not a polynomial equation involving the x. This is not a polynomial equation involving the x. This becomes a trigonometric equation. Becomes a trigonometric equation because the sine ratio comes. So that reason it becomes a trigonometric ratio. So here in the same manner, this is not a polynomial in derivative. So it is not a polynomial in derivative due to the sign of dy by dx. I'll just do the thing. When the differential equation is not a polynomial in dy by dx, means if in case e power dy by dx or e power any derivative, trigonometric ratios of any derivative like that. In this manner, in this case, the given differential equations are not a polynomial. In this case, the differential equations are not a polynomial in derivative. Polynomial in derivative means derivative of the dependent variable with respect to the independent variable, whatever the power it might be there, when whatever the coefficient you can write it, no matter, but in case of angle or exponential power, if it is there means it is not a polynomial. It is not a polynomial. Just compare this polynomial equation and this one. Is that clear? I hope you people are clear about this one. And one more equation I just write. Tell me whether that is a polynomial derivative or not a polynomial derivative. D square y pi dx square whole cube plus sine of x into dy by dx is equal to 0. Whether this equation is a polynomial in the derivative, yes, obviously it is a polynomial in derivative, because check that derivative, whatever the number of time you can differentiate, derivative coefficient, whatever it might be there, either x or whatever the real number or whatever the trigonometric ratios or the exponential function, doesn't matter. Yes, but here also that here it is a coefficient is there, no issue at all. So it is a polynomial in derivative. It is a polynomial in derivative. In place of angle, derivative should not be there. In place of angle, a derivative are there. This is not a polynomial in derivative. In place of angle x is there, doesn't matter variable. Then into dy by dx is there. Sin x is the coefficient of the variable. Sin x, a2, a1, a3 are the coefficients of the variable. In that manner is there, no problem. Now tell me, what is the order of this differential equation? Order equation, highest order derivative is there. What is the highest order? Order of this differential equation is 2. Order is 2. Is that clear? Order of this differential equation is 2. Okay. So now degree of the differential equation. To study the degree of the differential equation, first of all, a given differential equation must be present in a polynomial of the derivative. Polynomial of the derivative means y dash, y double dash, y triple dash, whatever the highest order of that should be in terms of the variable. That should not be present in terms of trigonometry, angle base or exponential breaks. This should not be present. Okay. Now degree. What is the degree of the differential equation means? Degree of the differential equation means the highest power of the highest power of the highest order derivative. Highest power of the highest order derivative. Highest power of the highest order derivative of the dependent variable y with respect to the independent variable. That is understood. I am not going to write here. What is the degree of the differential equation? The highest power of the highest order derivative. Simply just remember this much only. The highest power of the highest order derivative of the dependent variable with respect to the independent variable. In the examination, if they ask definition, means you have to write that. For remember purpose, just remember highest power of the highest order derivative. Highest order means order of the differential equation means maximum. How much time they are differentiated? That is our order. Highest order derivative means the highest power of the highest derivative of the differential equation. Degree means the highest power of the highest order derivative. First of all, come to here. I need to write the degree. I just wrote this one. Here order degrees and then say I'm just going to write. Okay. Here order is over. Now I'm just trying to write the degree. What is the degree of the this one? What is the degree definition? The highest power of the highest order derivative. Already the highest order derivative is written. What is the highest order derivative? First order derivative is there. What is this power? Highest order power. Power is 1. Degree is also 1. I got it. Highest power. What is the order of the differential equation? Highest order. Order is that. Order means order. Highest order is what? First order is that. First order derivative. What is the power of this first order derivative? Power of this first order derivative is 2. Therefore, degree of the differential equation is highest power of the highest order derivative. Next, come to here. Third one. What is that? Order. Order is 2. Order of the differential equation. That whole power how much? Yeah. Nothing is there means obviously it is 1. Therefore, the degree of the differential equation is 1. Degree of this differential equation is 1. Next, come to here. What is the highest order? Highest order is 2 is the highest order 2. What is this power? Whole power 1. Therefore, degree of the differential equation is 1. Next, what is the highest order? Highest order is 1. Then what is the degree? Here the degree is not defined. Why the degree is not defined? Because to define the degree, this condition should be satisfied. What is that condition? The differential equation must be present in a polynomial of derivative, but it is not in a polynomial of the derivative. Why it is not a polynomial of derivative? Because sin of dy by dx is that in place of angle, derivative is that, therefore it is not a polynomial in derivative. So in this case, the degree is not defined. In this case, degree is not defined. When the degree is not defined, degree is not defined whenever differential equation is not in the polynomial of derivative. In such case only the degree is not defined. Other cases degree is defined. Are you clear? One thing. Next, come for the sixth one. What is the order of the differential equation? Order means highest derivative of the dependent variable with respect to the independent. Highest derivative. Maximum result of the differentiation order 2 times. This is order is 2. What is the degree? What is the degree? Highest derivative power. Degree is 3. Degree is 3 or degree is not defined? Degree is 3. Why degree is 3? Yes, obviously it is a polynomial derivative because the sin x is a coefficient is that, nothing to worry. Derivative coefficient is sin x. Obviously it is a polynomial in derivative. Okay, very important thing, writing the order and the degree. Is that clear? Here, very important, definitely one question will be there for the 2 mark session. Write the order and degree of the differential equation. Writing the order 1 marks, writing the degree 1 marks. So order is, there is no confusion for writing the order. You can easily write the order, highest and derivative, that how much time they have differentiated, that we have to write the highest power of the derivative and write it. So by writing the degree, first of all you have to check that whether the given differential equation is present with the derivative, polynomial and derivative or not. To check the polynomial and derivative or not means just simply remember that a simple thing is it should not be present in an angle base trigonometric ratios of dy by x should not be there, and exponential function or exponential power in place of x, e power derivative should not be there. In such cases, the degree is not defined. In such cases, degree is not defined. Remaining all cases, degree is defined. So, several things are there. I am just explain later while giving the example or exercise based on this order and degree. First exercise is that. Now, better to directly begin the first exercise. So before that, we just mention all these 6 examples. All these 6 examples. We just mention these 6 examples. One side examples, at the right hand side of the same page, order and the degree. Simultaneously, we can compare it. We can easily write it. Now, let us begin the exercise to deal the or to write that order and degree of the differential equation. Yes, example, find the order and degree if defined of each of the following differential equations. They are given differential equations. For these differential equations, we need to find the order and degree if defined. Order is defined for every differential equation. Degree is defined only a differential equation, polynomial and derivative. Okay. Now I am just going to write the order and degree. What is the order of the differential equation and what is the degree of the differential equation? Order definition is that what is the order? The highest order derivative. The highest order derivative of the dependent variable with respect to the independent variable. Highest order derivative present in the derivative differential equation. Yes, it is a differential equation because derivative is that of the dependent variable with respect to the independent variable. Highest derivative. How many times they are differentiated? Only one time, because dy by dx is the order is one. First order derivative. Degree. What is the degree? Definition. Degree. The highest power of the highest order derivative. Highest power of the highest order derivative. Highest power. They are not mentioned any power means obviously it is 1. The degree is also 1 because it is a polynomial in derivative. Polynomial in derivative. Cos of x is there. No problem. But cos of derivative should not be there. Is that clear? Trigonometric ratios of derivative should not be there. Okay. Yes, obviously it is a differential equation, particularly ordinary differential equation, first order derivative and degree is also 1. Is that clear? And order and degree both are a positive integer. We can make the note. What is the note? For the given differential equation, order and degree is defined, then both are positive integer. Order and degree are positive integer. Now for the second one. Yes, obviously it is a differential equation because derivative is present. Derivative of the dependent variable with respect to the independent variable is the. What is the order? Highest order. Maximum lesser the differentiation matter not. How many times they are differentiated? Maximum. Here d square y by dx square is that. Dy by dx whole square is that. Y into dy by dx is that. Highest order derivative. This is dy by dx. First order square they have taken. Here highest order derivative. What is the highest time derivative they have taken? 2 times they have taken. So this order is highest time derivation. Highest term differentiation is 2. Next, degree. What is the degree? Definition. Very carefully observe the definition. What is the definition? The highest power of the highest order derivative. Highest power of the highest order derivative. We have to choose the power value of what? Highest order derivative. Highest order derivative is then. This highest order derivative power is how much? They are not mentioned anything is power is always 1. Degree is 1. Check it. Mistakenly don't write the degree is 2. It is not a degree. 2 is not a degree. Why? Because this 2 is not the highest power of the highest order derivative. It is not a highest order derivative. Highest order derivative is here. This power is 1. That is our degree. Very simple. Next, come to here. Here y square is that. Y square means y into 1. It is not a differentiation. Okay. Y triple dash. That means y triple dash is nothing but dq y divided by dx cube. Representation notation. Well, already familiar. Okay. Now here y cube y triple dash plus y square plus e power y dash is there. What is the order? Highest order. Maximum. How many times they are differentiated? Maximum 3 times they are differentiated. So the order is 3. Order is 3. Next, what is the degree? What is the degree? Highest power of the highest order derivative. Can I write it as degree is 1? No. Why the degree is not 1 means it is not a polynomial in y dash. It is not a polynomial y dash because of exponential e power derivative is the e power derivative means it is not a polynomial in y dash. So therefore degree is not defined. In this case degree is not defined because this is fact. It is not polynomial in. It is not a polynomial in derivative y dash. It is not a polynomial in y dash. Therefore, it is degree is not. Order is defined, nothing to worry. But degree defined, if defined, they only mentioned that. Order is defined for every differential equation, nothing to worry. Only the degree defined, not defined. When it is defined, whenever a differential equation is polynomial in derivative. When it is not defined, a differential equation is not in the polynomial of derivative. This is how we have to write the order and degree. Now let us move to the exercise problems. So very simple problems are there. I just make the exercise problems. Exercise 9.1. In that first one, what is the first one? d4y divided by the x power 4 plus sin of y triple dash is equal to 0. What is the order of the differential equation? Highest order derivative. Highest time. How many times they are differentiated? Highest time. Here thrice they are differentiated. Here 4. So order is 4. 4 times they are differentiated. What is the degree? Degree is defined or not defined? Degree is not defined because sign of derivative is that. Sign of third order derivative is that. So that degree is not defined. Why the degree is not defined? It is not a polynomial derivative. So that degree is not defined. Next one. Third example I just take. ds by dt 4 power 4 plus 3 into s d square s divided by dt square is equal to 0. Yes, write the order and degree of the differential equation. What is the order and degree of the differential equation? What is the order? Highest order derivative. What is the highest order derivative? Here ds by dt is the d square square dt square is the. What is the ds by dt? Yes, displacement t time you can take it. So yes, displacement is dependent variable or independent variable? Dependent variable. Time independent variable. Displacement is dependent. Time is independent. Okay. So here yes is nothing. In place of y, yes is that. In place of x, t is that. Okay. Yes, obviously it is a differential equation. What is the order of the differential equation? Highest order derivative is present. What is the highest order derivative of the dependent variable with respect to the independent variable? Highest order is 2 is that. So order is 2 because twice they are differentiated. What is the degree? Obviously it is a polynomial derivative. So degree, highest power of the highest order derivative is 1. Degree is 1. Is that clear? In this manner. Now take the next one. Fourth one. d square y by dx square whole square plus cos of dy by dx is equal to 0. What is the order and what is the degree? What is the order and what is the degree of the differential equation? Order, highest order derivative, highest time derivative. How many times they are derivated? 2 times they are differentiated. Next, what is the degree? Degree is defined or not defined? Degree is not defined because trigonometric ratios in place of the angle derivative is that. So degree is not defined. Okay, very simple. 2 marks question they used to ask. So write the order and degree if defined of the differential equation. Any of the one equation there is to do. For writing the order 1 marks, for writing the degree 1 marks. Next one. Sixth one. Y triple dash whole square plus y double dash whole cube plus y dash whole power 4 plus y power 5 is equal to 0. Write the order and degree. Highest order means highest order derivative. Maximum, how many times they are differentiated? Maximum, here twice once. Y power 5 means y. Okay. Maximum time differentiation is 3. Order is 3. What is the degree? Degree means highest power of the highest order derivative. Order for mere other maximum power is order highest order derivative. Power is 2. So that will be 2. Okay. Next. Eighth one, y dash plus y is equal to e power x. Y dash plus y is equal to e power x. What is the order and degree? Order. Highest order is 1. What is the degree? Degree is not depend or depend? Degree. Degree is 1. E power x is there. E power derivative should not be there. Obviously. Is that clear? E power x no matter at all. Are you clear? E power y no matter at all. E power derivative should not be there. Then only the degree is not depend. In any case, degree is depend. Highest order is 1. Once they are differentiated, whole power is how much? 1 is there. That's all. Next. 10th one. Y double dash plus 2 into y dash plus sine of y is equal to 0. What is the order and degree of the differential equation? Highest order. Maximum how many times they are differentiated? Twice they are differentiated. Order is 2. What is the degree? What is the degree? Degree is 1. Check it. Highest order. Maximum twice they are differentiated. Whole power is how much? 1. But sine y is the no matter what we need. Polynomial in derivative is required. Here y is the no issue at all. Polynomial in derivative. Sine of derivative. Whatever the order, derivative should not be there. But sine of y, no problem at all. Degree is defined. Okay. Only point to many to worry. Very important thing. Just remember the point. Trick is that. Don't confuse yourself because very important for the 2 marks issue. That's all. Next thing is last problem. D square by dx square whole power 3 plus dy by dx whole square plus sine of dy by dx plus 1 is equal to 0 is equal to 0. What is the order and degree of the differential equation? Highest order derivative. Highest order derivative is how many times? dy by dx, dy by dx, d square by dx square is that. So it is highest order is 2. Next. Degree. What is the degree? Sine of in place of angle derivative is there, so that reason degree is not defined. Degree is not defined. One more problem. Okay. D square y by dx square whole power 3 by 2 plus dy by dx whole power 1 by 2 is equal to 0. Is equal to 0. What is the order and degree of this differential equation? What is the order and degree of this differential equation? As I mentioned, note order and degree both are in terms of integer. Both are in terms of integer. This is little bit change this one. 2 times of d square y by dx square into dy by dx. Now write the order and degree of the differential equation. So note is that what is the note? Order and degree both are integers, positive integer. Here observe that highest order derivative. What is the highest order? Highest order is nothing but this one is the highest order is that highest order present. Therefore, it is the second order. Is that clear? Next, degree. To define a degree, degree means highest power of the highest order derivative. Highest power of the highest order derivative is 1 by 2 is 0.5. Can I add the 3 by 2? Which is not possible because order and degree both are integer. It is not an integer. In this case, we will do. In this case, we have to do that. Raise the power. We have to increase the power squaring on both sides. We have to do that squaring on both sides because we have to eliminate this one. To eliminate this one, I will just raise this power as a raising the power a plus b whole square, a square plus b square plus 2ab we will get it. So a square plus b square. Here plus 2ab. This 4 times we will get it. So anyhow, this is power is comes up 3. 1 by 2. 2 into 1 by 2 will cancel. 3 is comes. So that degree is 3. Degree is 3. So this is how we have to write the order and degree of the given differential equation. Very important for the 2 marks. Okay. Now obviously in the 2 mark session, one question definitely will be there. Write the order and degree. So make sure that how to write the order, how to write the degree. Nothing to worry. Order easily baridu. Degree barivaga one ಸ್ವಲ್ಪ careful ಆಗಿರಿ. Trigonometric ratios of angle place of derivative ಇರಬಾರ್ದು, exponential power ದಾಗ derivative ಇರಬಾರ್ದು. ಉಳಿದ ಕೇಸ್ y ಇರಲಿ, nothing to worry. ಅವಾಗ ಏನಾಗುತ್ತೆ, degree is defined. Okay. Now I just stop here. Remaining problems of the exercise 9.1 you better complete it. If you have any doubt, send it in the groups. Okay. Now I just stop here. We will continue the next video. Thank you.